In this question we have water flowing through a 150mm diameter pipe, and we're told the relative roughness, and just remember that's the roughness of the pipe divided by the diameter, and that's 0.0002. We're given the volumetric flow rate, so we need to calculate the pressure drop. So just to remind you, this, because we know the diameter and the flow rate, and we're trying to find the pressure drop. This is a type 1 problem, and we need to find the pressure drop over the 100-meter length, and we're also given the fluid properties of viscosity of water. So, because we know the diameter of the pipe and the volumetric flow rate, we can calculate the velocity using the volumetric flow rate is equal to the area times the velocity through that area. Once we have that velocity, we can calculate the Reynolds number because we know the density and the viscosity and also the diameter. So that gives us a Reynolds number of 8.5 times 10 to the 5. And we can then use this on the Moody diagram to find the friction factor, to find the pressure loss. We don't need to calculate the relative roughness as we've already given it in the question. So if we look on the Moody diagram, we have a Reynolds number of 8.5 times 10 to the 5, which is there. We have a pipe roughness which was 2 times 10 to the minus 4, so we're on this line. So just to remind you, we need to find out where these 2 points intersect and then read off on the left hand side what the friction factor is. So the two plots intersect around about there, and if we read that off, that gives us a friction factor of 0.015. So that's what it was from the graph. The friction factor we read off was 0.015. And just to show you, you could use the formula. So this formula allows you to calculate the friction factor directly. And if you do that, it's slightly more accurate, but you can see this is good enough. It comes out at 0.0147. So we put that into the Darcy Weisbach equation. So the friction factor times the length times the density times velocity squared, all over twice the diameter. And if we do that, we end up with the answer of the pressure loss, which is 157 kilopascals.